So we're starting today by reminding ourselves what y equals x looks like. Now, first of all, notice that this equation, it doesn't have like a squared in it or an absolute value or a square root, none of that fancy stuff. And so that tells us that the shape of this graph is going to be a line. So I know that it's going to be a line. The question is, though, where does it go? Well, it's not moved up or down at all. And so I know that it's starting at 0. And then, like so many of our graphs, it starts by going over 1, up 1. But since it's a line, it just keeps going over 1 and up. And we get our graph of our line.
Oh, I could have known that.
Okay, no problem. Well, today we're taking a look at situations like this, where we have something multiplied by our equation. So in this case, 4 times x. So if I take 4 times x, how would that graph look? Well, it doesn't move it up 4. And actually, let's see what it really does. Let's grab a couple points. What if x is 0? What's 4 times 0? 0. Anything times 0 is going to be 0. And so that means I'm still starting at 0. So that didn't change. Notice the 0 point didn't change. That tells us it's not being moved in any way. Okay, what if x is 1 then? Well, then we're doing 4 times 1. That gives me 4. So that tells me I'm going up there. Before, I went over 1, up 1. In this case, I'm going over 1 and up 4. What if x is 2? Well, then we're doing 4 times 2, which is 8, yeah. And thank goodness, because you'll notice that for this first one, if I go over 1 and up 4, I keep going over 1 and up 4. Otherwise, it wouldn't be a line. A line has to go by the same thing every time. And in fact, it's going to do the same thing going down and over as well. And so it's like I'm taking the original y equals x graph that I had here, and I'm taking each of these points, and I'm actually stretching them out. So you notice they're going further away from the x, and it pulls our line to be steeper. This trait right here is going to be exactly the same for any graph that you see that's multiplied by some number. It's the fact that it's multiplication that tells us that we're doing this kind of a stretch. Now today what we're going to be applying it to, though, is the wave function. That made up wave function that I had you working with earlier this week, we're going to be working with it more today. And so, just a reminder, this is what wave of x looks like. Wave of x, well, it looks like a wave. And so, what we're going to do is we are going to change the way this graph looks. We're going to change the way it looks by multiplying it by 4 here. So I'm going to actually show how we find the graph of 4 times wave of x. Now, whenever you're graphing one of these wave functions, I suggest that you go back to the original function that's drawn right above where you're doing this work and start by just copying that graph into your answer exactly as you see. And so the first thing I do is I'm going to do this graph. Now, a little side note here. The tools that you see, there's 2 different buttons. They both can make the same graph. But which one does what? Well, they both will work, so I suggest you just keep using the first one. The only difference between them is that the second one would put your first point like in the middle, and then you would go to the top. But we don't need to do that. Now, when I made the copy of this graph, I am using this button. You'll notice that where the little red dots are in this button, it shows them at the top and the bottom of the wave. And you'll notice the little red dots here. That's showing where those points actually plotted. Now, I could have plotted them instead of at those 2 points. I could have gone here, and then I could have maybe plotted the other one here. Or I could have gone top here, and then I could have gone bottom here. It doesn't really matter. We just need one of them that's at the top of the wave and one of them that's at the next bottom of the wave. Now let's go ahead and apply the 4 here. Let's see what the 4 is going to do to our graph. Well, this first point here, notice my y value is up at 1. That's saying that I'm taking the regular wave value, which is 1, and I'm going to multiply it by 4. Well, 1 times 4, of course, gives me 4. And so that tells me that this point is actually going to be plotted up here. So when you're doing this work, you're literally going to plot these points as you see it, but then drag that first point up to 4. Because we multiplied that height by 4.
Is that going to change the whole?
And we actually then have to do the same thing with this point. Right now it's down at -1, notice. Well, what's -1 times 4? Well, that'd be -4. And so then that point also gets dragged, but it gets dragged downward, this time down to -4. And so notice that what multiplying is doing is it's pulling our graph both up and down. Basically, we're pulling it away from the x-axis. When you do that, this is what your graph is looking like. Notice our graph is taller. Our wave is taller. The width wasn't affected at all, but it is now taller. 4 times as tall, to be specific. We call this a vertical stretch by a factor of 4 in this case, but a factor of whatever the number is. A vertical stretch takes whatever your graph is and it pulls it outward. And it pulls it outward from 0. Now with that in mind, one thing I want to show you that didn't change. My original graph, for instance, it went through all of those points. Notice even after stretching it, it's still going through the same points. It's because if you take 0 and multiply it by 4, you still get 0. And so that doesn't change. What does change is the height. It's both being pulled upward and downward, remember. This is not the same as a shift where everything's going the same direction. It's a stretch.